All right, so now we're going to talk about taking a curve like y equal f of x, which looks something like this, and we're going to revolve it about the x-axis. So we're going to make a three-dimensional solid, but what we're going to be doing is we're going to be finding the surface area. So they're coloring the outside of it. So how we do this, what we think of it as, we take the circumference, which is 2 pi r, and then we give it length. So 2 pi rl is the idea behind this integral. So surface area in general will be 2 pi r times the arc length. Well, we already know that this represents the arc length. The radius will depend on which axis I'm revolving around. So if I'm revolving around the x-axis, then y equal f of x is the radius. Y equal f of x is the radius if I'm revolving around the x-axis, because that's the radius for this circle. All right, so let's go for it. These integrals are going to be a little more challenging because I have a function out here and I've got the 1 plus the derivative squared on the inside. So let's start off with taking the derivative. So 1/2 4 minus x squared to the negative 1/2 power times negative 2x. All right, so I'm going to put double stars here because this is the place that most people make mistakes. It's easy to forget that negative 1/2, and it's easy to forget to take the chain rule. So you need to do both for the derivative of this. So if I'm going to write this, the 2's cancel, so I get negative x over the square root of 4 minus x squared. I think this is the easiest way to write it. It'll help us where we substitute it in here. So 2 pi, the function is 4 minus x squared. The square root of 1 plus, and I'm going to put the derivative in here, squared. And they'll always give me the limits of integration, so I got it right there, negative 1 to 1. So 4 minus x squared. So I have 1 plus, and so from this being squared, I get a positive x squared over a 4 minus x squared. So we know that root a times root b is equal to root a times b. That's a property of square roots. So let's do that. Let's put these radicals together. Let me just show you slowly. So I'm going to take the 4 minus x squared, and I'll be distributing it to these two terms in here. All right, so this times this will give me 4 minus x squared, plus this times this term will give me a plus just an x squared. Well, look at that. That looks quite a bit easier. Negative 1 to 1 for limits of integration. So the 2x squareds cancel, so I'm left with root 4, which is 2. So integral of 2 dx between negative 1 and 1. So 2 pi times 2x between negative 1 and 1. I guess I could say that is 4 pi. Substitute in 1, subtract off the negative 1, so I get 2 out of there. So 8 pi is the surface area. All right, let's do another one. So this one has still being revolved around the x-axis, but this is showing us that we can do it dy integration. Actually, let me stop here so that I can do this in a separate example. So this is doing dx integration, revolving it around the x-axis. This problem here, I'll be doing dy integration, revolving around the x-axis. You can do both.